Hello guys, welcome back to Mr. Brown's Secondary Science. Today we are doing, as said by the title, Nuclear Equations Examples. I have already put a video out there which explains how nuclear equations are done. I will link that video in the comments and put a hot link on the screen here now. So if you need to go back and check that, please do. But for now, straight into the example questions. Firstly, we're looking at bismuth 211, just here, decaying by alpha radiation. That's alpha radiation. And we can remember that alpha radiation, that has the mass number of 4. It has a proton number relating to its charge of 2, positive 2. So here, to balance this out, we will need, for the 211 mass number on the bismuth, we will have to subtract 4. So this number here, it goes from 211 in the bismuth to, on the new atom, being 207. 211 subtract 4, giving us 207. On the bottom, the proton number, we now, rather than subtracting 4, we are subtracting 2. So 83 for the proton number on the bismuth, it becomes, yep, you've got it, 81. That one's complete. We've already done the first question. Now for the second question, we are looking at the decay of polonium-204, and again it is decaying by alpha radiation. So we know for alpha radiation we have 4 our mass, 2 our proton number on the alpha particle. And now same process again, polonium-204. 204 is the mass number, it is losing 4, minus 4 there, so that gives us 200 for the mass on the new atom. And next, same again, now we're dealing with the proton number, it's minus 2, and that gives us a new proton number in our new atom of 82. That is another alpha question done. Next up, strontium-90. Strontium-90, and we can see in the question it is decaying not by alpha radiation, this time it is decaying by beta radiation. Now beta particle, it's an electron. We know that it has negligible mass, next to 0 mass. So we'll put 0 for its mass number, and we will put at the bottom for its proton number is going to be minus 1, relating to the negative 1 charge of the electron, which is a beta particle. So from that, no mass. So no change in the mass number from the original atom to the new one. So this stays as 90. The mass number stays the same. But for the proton number, balancing out the minus 1 we have here, we must plus 1 to this proton number. So that takes us from 38, adding 1 to 39 on the proton number here. And with that, this question on beta radiation is done. So the key points. It's all about taking away or adding numbers to the mass number or proton number. For the mass number, every time for an alpha particle you take away 4. And for the proton number you take away 2. For the beta particle, slightly different. For the mass number it stays the same. There is negligible mass in a beta particle, in an electron, so it stays the same. And the proton number goes from, it's not minusing 2 this time, you are adding 1. that is it. Now, as a final point, something that was pointed out to me in my last video, for the alpha particle, you may also see it referred to as the nucleus of a helium atom. Nucleus of a helium atom. Why? Because they have the same exact structure. They have 2 positive protons and, without charge, 2 neutrons. The 4 particles which have mass, which is where, actually, just highlighting it again, the mass number of 4 comes from, and 2 protons, 2 positive protons, it gives it the proton number of 2. So that was another episode of Mr. Brown's Secondary Science, going through those examples. If this has been useful, please do subscribe, hit the like button. If there is a topic you'd like me to cover that you think would be very, very useful, by all means do let me know. That's it for now. I shall see you next time.